Hi everyone, in this video we're going to have a look at solving cubic equations. Okay, so after we have learnt about our division of polynomials and factor theorem, we can solve higher order polynomials. Okay, this applies to null factor law, which is if a times b equals 0, then either a equals 0, b equals 0, or both. And this null factor law that we've seen for quadratics, okay, still holds true no matter how many terms we've got. Okay, so what we're talking about that is in the past, we've seen that we might have factorized a quadratic to be x plus 2, x take 3, okay, and we want to solve that equal to 0, okay, and that's to find our x-intercepts. Okay, we use the null factor law to say, well, x plus 2 equals 0, or x take 3 equals 0, therefore x equals minus 2, or positive 3. Okay, so essentially that's all we're doing. Okay, we've seen how to factorize our cubics now, so we end up in a form like this through division of polynomials. It's really just the last step. Okay, that being said, in this section they do talk about a few different types of cubics here and how to deal with them. Okay, so we'll have a look at those. Okay, so for example, we could need to solve 2x cubed take x squared take x equals 0. Okay, now you might think, okay, I've got to find a factor, all that sort of stuff. Okay, use my factor theorem. Well, yes and no. There is actually a factor here that's really obvious. We have actually an x in all of our three terms because we don't have this constant term at the end. So we can simply take an x out and say that we're left with 2x squared take x take 1, okay, equaling 0. Okay, and now we have this quadratic that we can factorize. Okay, and using any of our methods that we have available to us, we can factorize it to be 2x plus 1 and x take 1 equaling 0. Okay, now we can do the null factor law. Now what's really important is we don't forget about this x here. Okay, that's still one of three terms that we've got. So we say, therefore, x equals 0, okay, that one, 2x plus 1 equals 0, right? Or we can have x take 1 equals 0. Right? Therefore, okay, this one doesn't change. We still have our x equals 0. Or we take away 1, divide by 2, so x equals 0, or negative a half, or for this one, 1. Okay, just simply by switching across the other side. Okay, so we say x equals 0, negative a half, or 1. Okay, so whilst it looks like we might have to do division of polynomials, we don't. Okay, for the next one here, okay, we've got x cubed take 4x squared take 11x plus 44. Okay, now we haven't seen it for a while, but we can actually factorize this one as well without using division of polynomials, and we can do it via grouping. Okay, so that's where we look for a group that can occur here and can occur here. Okay, is usually the way we look. Now we look here, okay, and we can actually see that we can take out x take 4 as a common factor here. Okay, and we can actually do it over here as well. Sorry, what am I saying? I ran the wrong way there. We can take out x squared from these ones, sorry, and leave us with x take 4. Right, and we can look here and we can also take out an x take 4 here and we'll be left with negative 11 times x take 4. Okay, and this is one of our factors. Okay, sorry, simply write that first, x take 4. Right, and then we go, well, what's left? There's an x squared take 11. Right, now we can go a little bit further with this now. We can just leave it till later because it doesn't really matter. Okay, so again, null factor law, we can say that x take 4 equals 0, or x squared take 11 equals 0. So we can say, therefore, x equals 4, okay, or in this case, x squared equals 11. Okay, therefore, x equals 4. We need to take the square root of it, and remember that we need negative root 11 as well as positive root 11, okay, as our possibilities there. Okay, so a little bit different. We use grouping for this. We have seen grouping in the past, but we haven't used it for a while. If you don't really use this method for your questions, I'm not too concerned. Okay, what we really need to lock in to be good at is that division of polynomials, okay? Which is what we're going to do with this last example here. Okay, so for this one, we're solving x cubed, take 4x squared, take 11x plus 30 equaling 0. Okay, so we need to find a factor. Okay, so let's try 1. So you get 1 cubed, take 4 times 1 squared, take 11 times 1 plus 30. Okay, we can see this will be 1, take 4, it's negative 3, take 11, negative 14, plus 30. Okay, well that's not going to equal 0. Okay, we can try negative 1. Okay, and when we do that, we'll also see that that does not equal 0 because we're going to be negative 1. Okay, take 4 is negative 5. Okay, plus 11 plus 30, that does not equal 0. Okay, so we can try, let's keep moving on through our options. We can try 2. So 4 times 2 squared, take 11 times 2 plus 30. Okay, and we find that does in fact equal 0. So that means that our factor is x take 2. Okay, remember we've got to switch our signs. So we've got x cubed take 4x squared take 11x plus 30. Okay, so doing division of polynomials is my preference for this section. Okay, so we go x cubed divided by x is going to leave us with x squared. Multiply back through, we get our x cubed times our x squared by negative 2 gives us negative 2x squared. Bracket, bracket, take away, line underneath. Do our subtraction, they're going to cancel out. Negative 4x squared, take negative 2x squared will leave us with negative 2x squared. Bring everything else down, we've got negative 11x plus 30. Hey, we go again. Negative 2x squared divided by x is going to leave us with negative 2x. Multiply back through, negative 2x squared plus 4x. Okay. Bracket, bracket, take away, line underneath. Remember that little sort of chant, that little mantra. Okay, they're going to cancel out. That's what they've got to do. Negative 11x, take 4x will be negative 15x plus 30. Okay, we keep going. Okay, divide this by x, leaves us with negative 15. Multiply back through, negative 15 times x is negative 15x. Negative 15 times negative 2 will give us positive 30, bracket, bracket, take it away. And of course, we do see that that's equal to 0. Okay, now once you got here, you shouldn't really skip this last step because you could have made a mistake somewhere, and that would be your guide that you've mucked it up. Okay, so we're not quite there. We haven't finished off yet. Okay, because at the moment we've got now x take 2 and x squared take 2x take 15. Now we need to factorize our quadratic. Again, use any of the techniques that you've got, but we need factors of 15. We're working with this negative 2, so we know one's going to be negative and the bigger one negative. And we can see here it's going to be take 5 and plus 3. And remember, what we're trying to do, that this equals 0. Okay, so now we can null factor law it and say x take 2 equals 0, x take 5 equals 0, and x plus 3 equals 0. Therefore, x equals 2, x equals 5, and x equals negative 3. Now remember the context of this question. We're doing this because it shows us now what our x-intercepts are. Okay, so we'd be solving this equal to 0 so we can do something like graph it. Okay, which is what we'll look at later on. This is my preferred method for you answering these questions as opposed to doing something like grouping. Of course, we saw that example earlier where you could we didn't have the constant term, you could take x straight out as a common factor. Okay, this process I think is a little bit more important for us to get our head around, so this is the one that I want to focus on. Hopefully, they'll get you through the questions on this section.